Okay, kids, 3-2, something I forgot there. I need to tack it on, so grab your 3-2 notes, put this piece on there. Coefficient of variation. This is changing S into a percent. All right, there's the formula. Get her down in your notes. You don't need, I don't think, this one. It's, again, the same thing, only with those other variables. What does the coefficient of variation do? It allows us to compare two standard deviations with different means and different units. So this is kind of wild, but I can take in, here's an example. So I got Verizon data, speeds at airports, and earthquake magnitudes. And here we have the mean of both of those. Again, we measure earthquakes in Richters, and megabytes per second is the data speed. So here is my standard deviation for both of them. And now we can see 91% compared to 25% shows us, again, how did I get the 91%? I took the standard deviation divided by the mean, multiplied by 100. And we can see that for the Verizon speed varies a ton more, 4 times as more, than the earthquake Richter scales. All right? Now again, that doesn't tell me a whole ton, because maybe speeds vary more than earthquakes do. So we have to be careful what we can conclude from here, but it allows at least some sort of apples to apples comparison. All right. Again, coefficient of variation. Now, 3-3, here we go. Last unit, we are measuring things as they compare to their rank. And we close with a graph called a box plot. Item number 1, z-score. What is a z-score? Oh, it's so exciting. It is the number of standard deviations away from the mean. Here's the formula. So again, let's look at this a little bit more carefully. We're taking a data item, xi, we're subtracting the mean, and then dividing by standard deviation. And that tells us how many standard deviations I am away. And a couple things about this. First of all, round to the nearest hundredth when you do a z-score. The properties. There's no units, because this is a percent. If it's positive, you are above the mean, negative below, and you are considered significant, right, as a data item if you are above 2 or, below 2 or greater than 2. So an example, this is platelet counts. When you take your blood, we're going to check to see is 75 considered a low platelet count. So the first thing we do is I subtract 75 from the mean, 239.4. I divide by the standard deviation, 64.2. Notice we have a negative number. Negative 2.56 is my result. So this tells me I am 2.5 standard deviations to the left. All right. Next, percentiles. We divide the group into 100 groups. Each group is going to be 1%. So it's kind of what it looks like, each of the groups, right, of the data. And so where any p sub x is the number of values less than x compared to the total number of values. So here's an example of that. We're finding the percentile. So we got these Verizon speeds, and we're looking at what is the percentile for 11.8. Okay. Well, notice 11.8 is there. I've circled it. We have, these are sorted, and above here we've got 20 data items. And so we can now see that 11.8 has 20 below, always take the below, divided by 50, the total, times 100. And so that's 0.4, and so that tells me 40. So this is in the 40th percentile. All right, 11.8. Which means that there are 40% of the data items below, and there are 60% above. All right. Now, let's say we know the percentile, and I want to know the data value, like what data value is in the 25th percentile. Item number 1, sort your data. Next. Okay, we're going to take L equals K divided by 100 times N. All right, so let's go through an example of that. Sometimes we're going to get a whole number, sometimes L will be have a remainder. All right, and so here we go. Um, 12.5. Sorry, K is 25. So I take 25 divided by 100 times 50. All right, now notice we have a decimal here, the locator. So 12 and a half. I'm going to round that up to 13. And now I'm going to go look in the chart. Dang it, I don't have my chart. Where's the chart? Ah, okay, so now here's my chart. Come back here, 13th number in the chart. Okay, so 10, 11, 12, 13, 7.9. There we go. All right, so coming back down here, 7.9. All right, so 7.9 is the 25th percentile in that set. All right, example 5, doing the same thing, only this time I am looking at the 40th percentile. And here when I do 40 divided by 100 times 50, I get a whole number. So now I can't round up. Well, so what we're going to do is we're going to find the 20th and the 21st. All right, go back to my chart. So here is the 20th, 11.6. Here's the 21st, 11.8. I'm going to write those two numbers down. And then we find the value that's between there, right? Find the average. So now I know that this is the 40th percentile. Okay? This is the item that is in the 40th percentile. All right. We close with kind of a simple concept. That was the toughest one that we just went through. Quartiles. Quartiles, as you might expect, is the 25, the 50, and the 75. We label those as Q1, Q2, and Q3. It's a method of dividing up the data into quarters. When we graph those, we create a box plot, and it's a graph of the quartiles on a number line. A couple other things. From here, we can create what's known as the IQR. The IQR is going to be the distance from Q1 to Q3, and that allows us to identify outliers, okay? Other than just saying the vague words like, oh, that number's way out in left field, right? We can now have a formula. Yay! All right, so what we're going to do is, and I'll do this an example of it, but this is like something you should probably copy down. So we take Q1 minus 1.5 times the IQR, and then we take Q3 plus 1.5. And anything that's beyond there is considered out of bounds. So let's look at a graph of our data sets of Verizon, Sprint, AT&T, and Mobile. And we can see here now from the spread, if I think about this as 25 percentiles, so 25% of my data is here, 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 and here. So this shows me there's a huge spread on the right, whereas most of my data is concentrated on the left. Two things I know, and I'm going to bring this up in just a moment. This is skewed right. Okay, the data has been stretched to the right. So if I were to graph this out as a box plot, let me get rid of all this for a second. It would look like this. It would like taper off. All right. This one is even more skewed right. That like the left whisker, we call it, is completely gone. All right. So this is like maybe something like that. Maybe even more extreme. Okay. By the way, in both these cases, there will be outliers in this area. There will be outliers in this area, as well as here. Now this one, my interquartile range, by the way, is right there. And notice that length is about the same as that length there. So that's about 100%, right, on that side. And on this side, it's really short. So there's no outliers on the left. But on the right, there probably are. Sorry, not on this last one, but in AT&T, Sprint, and Verizon. When you have a box plot, you always need to have a scale at the bottom like this. That helps us read the numbers, obviously. Okay. All right. We now create a 5-number summary. What is this 5-number summary? Well, we take our smallest value, our largest value. That's 2 of them. We take our median value. Now the median, you remember, is the middle. So this is the 50th percentile. By the way, that's called Q2. That'll break the data set up into 2 groups, right? And then we break it up again, and that becomes Q1. Okay, so that's, we find the median of the medians. Okay, that's the technique. All right, and so we can see, again, there's the box plot, the graph. We can see here's, again, the Q0, the min, the max. Here's Q1, here is Q2, and here's Q3. So there's the 3 different ways to describe skew. It's either right, none, or left. The data is stretched to the right if the upper values, so it's skewed right. If there is no skew, then we would say that it's symmetrical or that it's constant values. Okay, one last thing, a couple last things that close up here. Any data item, again, beyond 150% is considered an outlier. So there's the formula again. I don't know why I wrote it in here twice, but there it is. And when we look at a set of data, and I do the math, and I check it out, these data items out here are considered out of bounds. They're outliers, right? Because it's 150% beyond that IQR distance. So the graph then does not going to include the max because these are like so odd. So what we do is we take our graph and we cut it off here, right? We cut it off there. And then we just put like little X's out there. And that's going to represent then those outliers. Finally, tech tips. The best 2 ways to graph these, other than by hand, is with StatCrunch or a graphing calculator. And I'll try to make a little video of that and post that online as well so you can see how to do that. All right, that's all for me. It's a wrap.